Okay, so good afternoon, everybody. We're going to discuss few questions today. So this is week three lectures, and we'll discuss some of questions here. So if you see the question one, it is basically a reactions given to you guys, and you just need to balance the equation, and you need to find it out the x, y, and z. Now, if you see the options, so this kind of question you can just basically try using hit and trial method by putting one after another. And apart from that, if you just have a clear basic concept, in a balanced reaction is a reaction in which all the coefficient for a particular molecule is constant throughout the reaction. For example, at least in the reactant side and product side, right? So if you see the number of oxygens in this reaction, just let me zoom it out. So if you see the reactions here, and if I'll consider the oxygen only, then you can see that the number of oxygen present here is your two, right? So here we need to have two oxygen, right? So this is basically two because there is no other oxygens is there. So basically the only options exist with this is equal to 4, 4, 2. Now just let's recheck that. If you put here 4, y is equal to 4 and z is equal to 2. Now if you see that 4H plus, right? 4H plus 4 electron plus 4 electron is equal to, tell me, this is your 4H and we have O2. So if you consider this 2H2O, here we have 4H and your 2O, right? So this is how you need to balance the equation. Now we'll see this reaction, that which of this is not a part of the Nernst equation used to calculate the E cell. Now Nernst equation is one of the most important equation in electrochemistry, as we have discussed previously in the slide, to calculate the cell potential at non-standard state conditions. If you see the equation, what the equation basically says, if you focus here, that this E is equal to, the EMF is equal to E naught, that is your standard cell potential, minus 2.303 RT by NF log 10 Q. And Q is your reaction quotient. That is basically the product quotient but divided by reaction quotient, right? So the standard reaction potential gives us the voltage as a standard condition, that is at 1 molar of all solution at 1 atm for all glasses. The Nernst equation allow for the calculation of the cell potential E, right? Now E is equal to, if you just solve it, E is equal to E naught minus 0.0592 by N log Q. Now, if you see this reaction, or if you understand the equation in details, then you will find that we can calculate the standard cell potential, that is your E. We can calculate the number of moles of electrons transferred from NF, because F is basically Farad number, N is the number of electrons transferred. And the reaction quotient can be calculated, as we have discussed, basically using this formula, that is your product quotient minus products to the power product quotient divided by reactants to the power reaction quotient, right? So basically standard cell potential can be calculated, number of moles of electrons transferred can be calculated, and the reaction quotient can be calculated. However, the wavelength corresponding to the color of glassware used for the cell reaction, we don't need to calculate, rather you cannot calculate using this equation. Okay. Now if you see here, log A plus log B is equal to your log AB. Similarly, log A by B is equal to log A minus log B. Minus, it's converted to log A by log B. Okay. Similarly, log e to the power 10 is equal to your 1, and this is what about logarithm, right? Now, to read the statement that it is possible to construct an electrochemical cell using two half cell with same chemical reaction but different concentration. Now, if you understand the statement, it is possible to construct an electrochemical cell using two half cell, because in a cell there are two half cell with same chemical reactions. The chemical reaction is same, because suppose I am using one metal, suppose I am using one component, like Ag is converted to Ag minus, Cu is converted to Cu plus, and again Cu plus is converted to Cu minus, zinc is converted to zinc plus, again zinc plus is converted to zinc minus. So if this is the condition, can we construct a cell? And the answer will be yes. But what will be the condition? It should have different concentration. And that concentration difference will create a gradient based on which the electron will transfer through the cell bridge due to the difference in the concentration gradient, and that will create an electric potential and through which the electron will transfer, right? So if we'll consider this statement, so it will be true as it is possible to construct an electrochemical cell using two half cell with same chemical reaction but different concentration, right? Now the next question, number 5, you will see the reaction as we just right now I have described. Here what happened, the reaction consists of two system, two half cell. In one cell, the Ag, that is silver in solid form, is converted to Ag plus, that is in aqueous, that is 0.1 molar. In the second half cell, we have Ag plus, that is converted to Ag, right? But what is the difference? What is making this cell to function? What making the potential gradient to create it? What making the electron to be transferred across the cross bridge is the difference in the concentration gradient. Now, in the first one, you will see it has 0.1 molar concentration. However, in the second half cell, it has 0.5 molar concentration. So, if the concentration is more, it creates a partial gradient that is responsible for the transfer of electrons and results in the transfer of current. So, this is basically your concentration half cell or concentration cell. Okay. Now, if you see the question number 6, now how many moles of X4 plus are reduced to X2 plus by one coulomb of electric charge? Now, tell me that one coulomb of electric charge, what does it mean? That means that it represents a number that is basically 6.024 into 10 to the power 18. So, this amount of electron is responsible for how many moles of conversion of X4 plus to X2 plus? This is the question. Now, if you see, to convert from X4 plus to X2 plus, we need 2 electrons, right? Now, if 2 electron can reduce from X4 plus to X2 plus, that is one molecule. Now 6.023 into 10 to the power 23, that is your 1 mole. 1 mole is required how many electrons, right? 1 mole of electron will require how much electrons, right? And similarly, how many moles of cells can be converted to X2 plus, or how many moles of X4 plus can be converted to X2 plus using 1 coulomb of electric charge, that equal to 6.024 into 10 to the power 18 number of molecules. So you can get a basic idea, right? The number of molecules, it at the power of 10 to the power minus 23, it will be around at 10 to the power minus 10 to the power 18. So basically it is in micromoles only. Now if you need to calculate that how many micromoles, so you just find it out and let me know, and you should get the answer of 5.18 micromoles. Now the question is, I think, very much clear, that we just need to calculate the number of moles of X4 converted to X2 by one coulomb, that is 6.024 into 10 to the power 24 10 to the power 18 electrons. Clear? Now we'll see the next question is that calculate the potential drop required for 1 micromolar of electrons to do 1 joule of work. Now we all know that work is equal to, what is work basically? Work is equal to your, yes, tell me what is basically work. Hmm? Work is basically your QE. Okay. Now we need to calculate potential drop, that is E. E is equal to W by Q. Now we have W is given is equal to your 1 joule. Q is equal to basically your NF, right? In terms of electron. Now N is equal to your 1 micromole, that is equal to 10 to the power minus 6 into F is equal to your 9, 6, 5, 00. Right. So if you solve this, you will get around 10 to the power 4 electron, 4 volt. Okay. Now the other question is that coulomb is the unit of electric charge. Okay, we all know. Now when the experimental results are shown in current versus time, it is called, that's very simple one. Current का unit क्या है? What is the unit of current? It is ampere. And what is the time? What is the unit, measurement of time? It is called chronology. Right. So basically, it's called chronoamperometry. Right. So chronoamperometer is a techniques for the experimental results that are shown in current versus time. It is called your chronoamperometer. Right. Because ampere represents to your current, chrono represents to your time. Okay. Now by convention, oxidation occurs at anode. How? Because oxidation is loss of electron. Okay. So when a positive anode is what? Anode is basically an electrode in which cations are get, sorry, in which anions are get attracted towards, right? So it itself is a positively charged electrode, right? Now how it can be positively charged? By oxidation only. So oxidation is basically loss of electron that will lead to the electrode positively charged, right? And if it is positively charged, then only the anions will be attracted towards it, and this will be called your anode, right? So basically by convention, at anode the oxidation is occur, right? So it's clear. So this is what I had for you, and mm, any more doubt, just you can get back to me, right? So thank you for today, and I'll discuss further, right? Okay, thank you. Yeah. Yes, any doubt? So this is for your question answer. Okay. Yeah, I'll put the lecture regarding the theory part. Yeah. Yes. Okay, guys. I think you have your exams, and I think most probably are gonna get MCQs. And so yeah, we can discuss that thing just after this. Okay. So yeah, I'll be back in a while. Okay. Okay. Thank you.